Truth Revolution.
Hey, welcome to Truth Revolution. This is where faith and reason meet, although Jeff and I aren't really meeting right now. It's really weird, this whole COVID thing going on. But it is what it is, right? And I don't know whether this is the new normal, but this is the way things are right now. How you doing, Jeff?
I'm doing good, man. It's good to see your face.
Yeah.
Beautiful man.
I'm kind of in quasi-quarantine right now.
Yeah. Well, hey, we have a special guest today. We're talking about the COVID-19 vaccine. Talking about COVID. We're going to talk about whether or not Christians should do this. We're going to talk about whether or not aborted fetal tissue is used. What about the variant of the virus? But the main question is the vaccine safe? Is it effective? What's the Christian response to this? We're going to strip away conspiracy theories. We're going to talk a little bit about some of the conspiracy theories. Does COVID-19 actually exist or not? But that's going to be a little bit later. We're going to dive into the science of this. We got a special guest. Who is it, Dave?
Biochemist Rana from Reasons to Believe. He writes and speaks extensively about evidence for creation emerging from biochemistry, genetics, human origins, and synthetic biology. He's the vice president of research and apologetics at Reasons to Believe. He's dedicated to communicating to skeptics and believers alike the powerful scientific case for God's existence and the Bible's reliability. He's written several books, and he's done lots of interviews. Of course, he's been on Fox News, been on the John Ankerberg Show, been on Harvest Television, and he's appeared in publications across the globe. He's been a regular guest here at Truth Revolution, which is by far his favorite show. I'm sure of it. It's good to see you again, Fuzz.
David, Jeff, it's good to see you. And actually, no smoke blowing up anything, but I do really like your guys' show a lot. You guys are a lot of fun to hang out. So
Good.
When I got the invitation to be on your show, I was like, yes, get to hang out with Jeff and Dave again.
All right. Well, we always love having you here. Earlier this spring, we had a virologist, AJ Roberts, who was with Reasons to Believe at the time, and she talked about COVID and how serious it was. That was an amazing interview. Now we get to talk about the vaccine, potential cure for this. So I'm really excited. Give it to me straight. Is the virus something that Christians should consider taking?
The vaccine, yes.
That's right.
Yeah,
that's a bad mistake. Let me retry that. Is the vaccine something the Christians should consider taking?
Yeah, my advice would be avoid the virus, but I think the idea of the vaccine being safe and effective is real. I mean, I'm very impressed with the effectiveness of the Pfizer BioNTech vaccine as well as the Moderna vaccine. Both have been approved for emergency use by the FDA, and the effectiveness is about 90%, at least in the phase 3 clinical trial. I suspect as it moves into more broader public use, that effectiveness rate may drop a bit, just because of, in a larger population, you very well could get greater variability. But the vaccine also appears to be safe as well. There's nothing that's alarming in the clinical studies that suggest that the vaccine really isn't safe. But just as a point of reference, the seasonal flu vaccine that we get is about 40 to 60% effective. So a 90% effectiveness rate is really, really astounding and really good news.
When we say that, like the seasonal flu vaccine is 40 to 60% effective, is that because there's different strains of the flu, or is that just even if you get the right vaccine for the right strain of the flu, it's only 40 to 60% effective?
It's probably a combination of both, getting the right vaccine, for the flu, but also the vaccines elicit different types of immune responses, or at least different degrees of immune responses. And so that also contributes to the effectiveness. So people believe part of the reason these vaccines from Moderna and Pfizer BioNTech are so effective is because they are based on a quote unquote, a new technology, namely that these are messenger RNA vaccines. And that very well could be contributing to their effectiveness.
Yeah, we're going to definitely dive into the messenger RNA thing, talk about, is that safe? Because a lot of people are like, it's going to alter my DNA forever. That's scientifically almost impossible from what I understand. You're going to explain to us why. But now AstraZeneca, who's also developing a vaccine, theirs is not a messenger RNA vaccine. Theirs is basically a virus itself with some stuff inserted into it, right?
Yeah, well, the exciting news is that AstraZeneca has also got emergency approval, at least in the UK, for their vaccine. And it's a different type of vaccine that's based on what's called a viral vector, where, as you pointed out, Jeff, you're using a virus as the means of delivery for the gene for the spike protein of the SARS-2 coronavirus. So it's a fundamentally different type of vaccine. The clinical studies indicated about a 60% effectiveness, which is much lower, obviously, than the Moderna or the Pfizer BioNTech. But what's interesting, and this is the fun part of being a scientist, is that during the one stage of the clinical studies, or one of the arms of the clinical studies, somebody goofed up and they gave a lower dose than they were supposed to for the first vaccine dose. And it turns out that when they analyzed the data for that particular group, that with the first dose was lower than it should have been, and the second dose was what they were studying in the clinical trial, they actually saw 90% effectiveness. Nobody knows why. So, this is part of the fun of science. So it may be that vaccine actually is as effective as the Moderna, Pfizer, BioNTech.
That's one of those funny accidents where the scientist is back there scratching his head going, what just happened? And honestly, so I have a computer programming background, and this sort of thing actually happens in computer programming, where you'll write some code and something will happen and you're going, how did that happen? And you'll go back and you say, oh, I see what it's doing now. Right. And so I imagine it's somewhat similar.
Yeah. So, the road to success is paved by serendipity, I guess.
Yeah. Now, this is where a lot of the fears come from, though, because people say, hey, this vaccine, none of these three have had a significant amount of trials. I mean, sure, they put 38,000 people through this for each one or something like that. But we haven't studied this for years like we normally do. Let's focus mostly on the RNA ones, because those are the ones that are out right now in the United States. What are we supposed to do with the fact that these haven't been studied for years? Is there a big danger there?
Well, I mean, it is true that these messenger RNA vaccines are a relatively new approach to vaccinations, and that this is the first time that they've been approved for use in the general human population. But people have been working on RNA vaccines for over 30 years and have very carefully studied how they perform, in biological systems. They have done all kinds of effectiveness as well as safety studies in animals. And in fact, RNA vaccines were progressing to the point of phase 3 clinical trials with respect to other viruses just at the time when the COVID-19 pandemic hit. And so both Moderna as well as Pfizer and BioNTech literally had all the pieces of the vaccine ready to go. They just needed to know what RNA sequence to use. And they literally were able within days to go into animal testing and then into human phase 1 and phase 2 clinical trials. So yes, they are new. Yes, this is the first time they're being used in human populations, but we have 30 years of research data that has given us a really good understanding of these vaccines. And so they are not new in that sense.
That makes sense. So it's the technology isn't actually new technology. It's just a different application that we haven't used yet.
Right. And, given the fact that we are in the midst of a pandemic and the phase 3 clinical trials showed really such a high level of effectiveness and no obvious safety concerns, that there was no reason not to grant emergency approval. And under normal circumstances, there probably would have been additional clinical studies done before it was progressed to the point of being widely used. But again, there's really no reason not to. And really the biggest concern safety-wise would be for those people that have either autoimmune disorders or tend to have very strong allergic reactions to food or things in the environment. Those are people that probably want to avoid the vaccine, but for everybody else, all indications are the vaccine is going to be, safe.
Okay. Now let's get into the science of how it works, because I actually think once people understand the science behind it a little bit, it makes a lot more sense. When I got off the phone with AJ yesterday, I was like, oh man, this is amazing technology. And I read your article, which we're going to link to, and your article was great on helping this as well. So both of these vaccines are lipid nanoparticle formulated, nucleoside modified mRNA vaccines, they encoding the prefusion spike glycoprotein of SARS-CoV-2. What does that mean?
Yeah, well, in effect, what the heart of the vaccine is a messenger RNA molecule that encodes for what's called the virus spike protein. And so if people have seen images of the virus, it's this spherical structure with all the knobs sticking out. Those are the spike proteins, and those are what bind to the cell surface receptors. They're kind of like a lock and key that once they bind to the cell surface receptors, the virus gains entry into the cell. But because these are spike proteins and they protrude from the virus, these are great targets for antibodies in the immune system. And so what they have done is they have essentially produced a messenger RNA that encodes for the spike protein. And they've done some modifications to the messenger RNA to masquerade it from the immune system, because RNA in the immune system causes what's immunogenicity. It causes the immune system to treat it as a foreign particle. So you kind of masquerade it. The lipid nanoparticle that engulfs the mRNA also shields it from the immune system. There's also changes to the RNA to increase its stability. The lipid nanoparticle helps with that. It helps it also gain entry into the cell. But once inside the cell, that messenger RNA is converted into protein, and that protein then is presented to the immune system. And so you end up developing an immune response to the spike protein. But because it coats, again, the virus surface, you now have immunity to the virus itself. But the beauty of this is that this RNA breaks down very quickly inside the cell. It's not going to even make its way into the nucleus. So once it's done its job, it's broken down and eliminated. And you can't get a COVID-19 infection from the vaccine, which is different from other traditional vaccines that involve either a dead virus or what's called an attenuated virus. So it's inherently a much safer vaccine that's much more targeted with regard to eliciting a response in the immune system.
Right, that makes sense. So basically, you have your cell, and if we go back to fourth grade science, inside your cell is the nucleus. Your DNA is in the nucleus, right?
Yes.
And what people are afraid of is that this RNA vaccine is going to alter your DNA. But for the RNA that your cell accepts from the vaccine, so the RNA goes into your cell, it's in the cytoplasm. It's not in the nucleus. And it's virtually impossible for something to go, for RNA to go from the cytoplasm into the nucleus unless you have reverse transcription, right? Like HIV, like a purposeful action. Like how difficult is it for something to accidentally go from the cytoplasm into the nucleus and alter your DNA?
I mean, as you're pointing out, Jeff, it's virtually impossible for that to happen. And again, the RNA is going to be broken down fairly quickly inside the cell once it's translated, once it's used to make proteins. So RNAs are inherently unstable molecules. This is one of the challenges of getting RNA vaccines to work, is how do you keep the RNA stable long enough to make its way through the bloodstream to the target cells. And so that weakness also turns out to be an advantage once it's inside the cell, because again, it's going to be broken down very quickly.
So it really can't even stay in your system for decades and years as RNA.
Right. And in fact, there are specific things they have to do to the RNA to ensure that it's has enhanced stability, but also to make sure that it actually is even recognized by the cell as something that should actually be translated and made into proteins. So you've got to trick the cell to even use that RNA to make proteins. And again, the lipid nanoparticle is critical in terms of it making its way to the cell and making its way into the cell.
Okay, now you're the biochemist, so fix anything I say wrong here. But the normal process inside your body is that inside your nucleus you have DNA, and that can create RNA there, and that goes into the cytoplasm in your cells, and that turns into proteins which come out of your cell, and those proteins can inform your immune system of what to do, right?
Yes, yeah. So what happens is, once proteins are made, some of them will get incorporated into the cell membrane. Others will be broken down in the cell and then combined with something called the major histocompatibility complex 1, which kind of presents those protein fragments to the immune system.
What is it called again?
And what's that? Major histocompatibility complex 1.
Yeah, it sounds like a psychological disorder.
Well, yeah, for biochemists, the need to use these terms is the psychological disorder. But in other words, it's presenting fragments of the protein to the immune system. So your immune system will normally say, oh, these are just our proteins. But when a virus infects a cell, this is one way the immune system knows that viruses have invaded the body, is suddenly viral proteins show up on the cell surface. And that then triggers the immune reaction and then later helps to build immunity against that virus. So what you're doing is you're just using the spike protein instead of the entire virus to say, hey, here's something that's unusual. It's a spike protein. So now we mount an immune response to that and build up immunity to that. And again, the good news is because the spike protein is so prominent on the virus, it makes us immune to the virus over time.
Okay. Now, one of the interesting things about this vaccine is that they're saying the vaccine gives you longer durability or more protection than if you actually get the virus. You have a better immune response, longer lasting than if you get the virus. Do you have any theories on why that might be?
I really don't, other than the fact that what you're doing is all the antibodies that you're building up are specifically to the spike protein. And so it gives you a very focused response to, a portion of the virus. And plus you're able to probably administer much higher doses of the spike protein to elicit an immune reaction versus being infected with the virus where the viral particle levels would be at a much lower level. So it could be a combination of those things, I would speculate.
Yeah. One thing virologist Roberts actually said, and I'd like your opinion on this, and she said it's a little bit of speculation, but it's possible that when the virus invades your cells, there's all sorts of information in that virus other than the protein spike. And so she says it's possible that there's something in that virus that's actually causing a problem with your B cells, making it harder for your body to remember, so to speak, the immune response. And so over time, your body forgets it. And that was part of the virus's design, so to speak. And so when you're getting the immune response from the vaccine, you're not getting any of that, hey, forget about me stuff that's coded in the virus. You're just getting the spike protein right away, none of this other information. And so your body can remember it longer. What do you think about something like that?
Yeah, that's quite possible. We do know that that the SARS-2 coronavirus does have certain proteins that it encodes in its genome that helps it to evade detection by the immune system. We don't quite understand that, at least to my knowledge, we don't understand that. And that could be, again, part of what's going on as well. So yeah, there's some, a number of possible mechanisms for why that's the case.
Interesting. Let's talk a little bit about long-term implications of taking the vaccine. As you said, they've studied RNA stuff for 30 years, but we've never tried it in humans before. What are the potential long-term implications, if there are any, 5, 10, 15 years down the road of humans taking this?
I have a hard time envisioning there would be any kind of long-term effects from being administered mRNA vaccines, simply because, as we are mentioning, that mRNA doesn't last very long inside the body. It gets broken down very quickly. It doesn't do any kind of permanent alteration to our genome. the lipid many of the components in the lipid nanoparticles are actually things that are naturally occurring in our bodies anyway. There's a few non-natural synthetic lipids that are part of that are playing a critical role in a number of in the vaccine delivery system itself. But those things are going to be cleared from our bodies. We've used those materials in other medicines and in other consumer products, so we understand how they perform in the body. So there's nothing that suggests to me there's going to be any kind of long-term effects from this particular vaccine. I would be much more concerned about potential long-term effects when we're talking about delivering attenuated viruses or even killed viruses as part of a vaccine. That's where I think you could have some potential long-term effects with vaccines. And
those are what the flu vaccine is, right?
Yes, that's most vaccines are actually of that nature. Now, apparently in China, one of the biotech companies there actually has developed a COVID-19 vaccine, and it's actually a traditional vaccine. I think it's an attenuated SARS-2 coronavirus.
That's interesting. Let's go ahead and talk about complications to the vaccine now. So you hear people talking about, and this is one of the, conspiracy theories or whatever, but people are talking a lot about Bell's palsy. I saw a video of a lady who claimed to be a nurse. And her face is droopy. She said, "I got Bell's palsy just a few days after taking the vaccine. Nobody take the vaccine. It's dangerous," that sort of thing. But the CDC says that they don't think they concluded that it wasn't much different than in the general public, the number of cases. Give me your thoughts. You've looked at the studies. What do you think about like Bell's palsy and some of the other complications? Yeah, well, it is true in both the Moderna study as well as the Pfizer BioNTech clinical studies that in each study, there were 4 instances of Bell palsy that was reported. And most people, as you're saying, like with the CDC, think that this is a correlation, not a cause and effect. And as you're pointing out, that the number of instances of Bell's palsy correlates very well with what you would expect if you took a sample of 70,000 people. That 8 people in that sampling are likely to have Bell's palsy. The fact that you have one individual that developed Bell's palsy immediately after the vaccine, again, could just simply be coincidental. But, the companies did indeed report these results as part of the safety package, with the idea that physicians can keep an eye out for this, that if this is actually happening, that maybe there is a cause and effect. But right now, it seems like a correlation more so than anything. Yeah. I participated in a drug study when I was back in college. I was dating Meadow, who I'm married to, and I wanted to ask her to marry me, but I didn't have any money, right? And so I found this drug study, and they were paying people $2,500. Actually, I think they were paying like $3,000, and it was.
This explains a lot, Jeff. It really explains a lot.
Well, okay, I'll tell the whole story then. So we're in the beds where they administer the first dose, and I don't think they were supposed to do it this way, but there was only 5 humans. This is the first time it was tested on humans. We knew that. We didn't know what it was for or anything, and we're all laying in our 5 beds together. They administered the drug to the first person, 10 minutes later, the second person, and so on. Well, about an hour later, the first guy, he sits up and he goes, I can't breathe. And the doctors and nurses rush over there and they're pumping him. 10 minutes later, the second person, I can't breathe. 10 minutes later, the third person, same thing. There's 2 of us left. I'm the 5th person, and the 4th person is looking at me and I'm looking at her, and we're like, oh, this is not good. We're looking at the clock. About 10 minutes later, nothing happens to her. And we're both like, she got the placebo. She got the placebo. I'm like, I'm going to die in 9 minutes. Nothing happened. And after that, they put us in separate rooms. But so I guess, all that to say, like, yeah, complications do happen. Like, that's a normal thing, right? This is a medical intervention, and there will be complications, right?
Yeah. That's a really good point, Jeff. And Great story too, by the way. Is that with any medical treatment, whether it's, a drug treatment or whether it's, vaccines or a surgical procedure, there are going to be side effects. There's certain people that are simply not going to tolerate that particular medical intervention. That's just the nature of medicine. And you try your best as you can to understand what could potentially go wrong and who would most likely be vulnerable. And again, we already do know that if for people that do indeed have strong allergic reactions, have an autoimmune disorder, they probably shouldn't get the vaccine, or they should be in close consultation with their physician if they're going to. There's no safety data on the effects of the vaccine on pregnant women or women who are breastfeeding. So that's, again, something that, if you're in that category, proceed with caution. No safety data on young children. So again, likelihood is we're not going to vaccinate young children the first go around. So there are categories where we know people probably shouldn't receive the vaccine, which is all that much more reason why those of us that can receive the vaccine should, because we can help build up herd immunity and protect those people who can't be vaccinated for legitimate reasons.
It's kind of interesting to me, actually, and it actually keys me in on, I think the government and these companies are trying to be very cautious, because as we look at it, and of course, we've only gone an inch deep. You go way beyond what we've talked about here, but it certainly seems like RNA type vaccines are going to be extremely safe. The RNA doesn't stay in your system. It just creates the proteins that affect the virus you're trying to get out of there. It can't alter your DNA, but they still, hey, don't get it if you're a child. Don't get it if you're under 16. They want to protect these classes they haven't studied. Seems like they really, really want to be careful here until they've studied it in depth, even though it looks like it's promising.
Right. And, and the exciting thing to me is that RNA vaccines are considered by many people to be the ideal vaccine. And so we are going to see more RNA vaccines in the near future. But the good news is that once you figure out how to get the chassis to work, all you're doing then is changing the RNA sequence. And that allows you then to develop immunity potentially with these vaccines to a wide range of viral pathogens like Ebola and Zika. And so as new pathogens emerge, we could very quickly have vaccines to respond to them. So this idea of a threat of a global pandemic in the future could actually be something that would be in the past, not something that we have to fear in the future, if indeed these RNA vaccines really are the ideal vaccine. So this could be a huge breakthrough in terms of treating viral infections as we move into the future.
That's fascinating. And I know there's second generation vaccines coming maybe in a year or two on this same thing. And, I'm a Star Trek fan. I like to watch Star Trek. And sometimes you see them traveling to some distant part of the galaxy and encountering some new virus, and their doctor creates a vaccine in his own lab in a matter of hours. That really seemed like science fiction in the 90s. But with this sort of technology coming, it doesn't seem too science fiction-y for very long.
Yeah, well, to me, this is where I see, God's providential hand, if I may, because, once we had the genome sequence for the SARS-2 coronavirus, which was in early February, people right away recognized that now that we have the spike protein sequence, DNA sequence, we can now very quickly manufacture that messenger RNA and plug it right into this virus chassis that we've built, and then go right into safety studies.
Wow.
And we were reaching that point of already progressing RNA vaccines into human clinical studies at the point where the COVID-19 pandemic hit. If this happened 2 years earlier, we would not be able to respond as quickly as we've been able to respond.
Wow.
So it's amazing to me that just that perfect time where we were ready to go with RNA vaccines, that's when the pandemic hit.
That does seem like
it's
God's
astounding
timing.
to think that we went in February from having the genome sequence of the virus to really in, the end of November, having the first doses of a vaccine being delivered to hospitals for people to be, to be vaccinated with.
Okay, so, we're gonna take a little break. If you're listening and you want the rest of this, go to truthrevolution.tv. That's truthrevolution.tv.
And we're back. We're talking to one of our favorite guests, Faz Rana from Reasons to Believe. Now, I'm sitting here. We're talking about the coronavirus. We're talking about the vaccine, the potentials of it. What does it mean? And there's a couple questions popping in mind. First, I want to kind of address something that Jeff, you and I have talked about before, and that's we're talking about miracles, okay? And it's not necessarily in what happens during the miracle, but the timing of the miracle. And Fuzz just kind of hit on that. If this had happened a couple of years ago, then we might have been ill prepared for it. But maybe God provided that miracle in the timing of that. Okay. The second thing that I want to kind of hit is, Fuzz, we've talked about with you on the show before, humanism 2.0 or human 2.0. Okay. Now, you talk about how we rely on science for our salvation. Kind of give me some idea of where you feel this falls into that kind of a push towards something like that, because really it does seem like Jeff brought up, it seems science fiction-y and pushing towards the future. What are your ideas on that?
Yeah, well, I do these once in a while, these Facebook live streams, and a few months ago I did a live stream where I pointed out that probably our response to the SARS-2 coronavirus and the COVID-19 pandemic is going to actually fuel transhumanism, which is the idea that science and technology can be the mode for our salvation. Because here again, science has solved the problem. But to me, the way I look at it is that really science is part of God's providence. It's God's gift to us as human beings, that because we bear God's image, that we're able to, understand the world around us, and turn that understanding into technology. That's part of being image bearers, and it's part of our mandate, as Christians and as humanity, is to mitigate pain and suffering in the world, and to love our neighbor as ourselves, to promote human flourishing. And so science and technology are the means by which we can do that. So it's, to me, I see that as part of God's providence. So while some people might see, science saving us here, I would agree science has saved us, but it has saved us because of God's providence. And providential care for us.
I totally agree. It's also interesting how we talk about science. I mean, even in our discussion, we've talked about science as though it's an actual thing. Just today, I was listening to the radio, driving somewhere to the car shop with my wife, and on the radio, someone was being interviewed, and she said, "I just want to thank science for getting us to this point where we can have a vaccine." And my wife looks at me and says, "I think she meant scientists." And I was like, wow, that's a big difference, right? Science, I mean, we talk about, man, I love science, but in reality, science itself isn't a thing any more than religion is a thing, right? We thank God. We don't say, oh man, I want to thank religion for, finding joy in my life. I want to thank God is the proper response. And it was actually scientists who did the hard work of digging in, going, hey, we've got a problem. Let's figure out how to fix it. And in some ways, it was the Christian worldview that provided the ability for people to discover new things. That wasn't the direction we were going with this, but I don't know, Fuzz, I know you probably have a comment about that.
No, I think that's well said, Jeff. And that's a really good point, is that it's not just simply, the fact that the world is intelligible and that we have the apparatus to understand the world, but we were given this mandate to subdue the world and to bring it under our control, to be caretakers of the world. And that's really a mandate for science and the development of technology. But, to your point, that the presuppositions that you need to even do science actually flow naturally out of biblical cosmology, out of a biblical worldview. There's no other philosophical or religious system in the world that has the worldview that actually naturally leads to the activity of science. And it's no mistake that science, modern day science, was birthed and flourished in Christian Western Europe, where the Christian worldview permeated.
Yeah, right. I mean, Hinduism says that, or Buddhism says, like, this is all just fantasy. This isn't real. Christianity, on the other side, says not only is this real, but by studying nature, you can understand your creator. And so, scientists like Newton, Kepler, Galileo, they all consider themselves theologians. I mean, they thought they were studying the mind of God by doing this. So let's get back to the COVID vaccine, though. I have a few things here I want to make sure we hit. All right, fetal tissue. Some people will point out aborted fetuses were used in the development of vaccines. Someone I saw on YouTube even said an aborted fetus was used for this vaccine. Fuzz, give us the actual data there. What should Christians be concerned about?
Yeah, and this is really kind of a complex ethical issue. So I'd be really interested in Jeff, in your take and Dave's take. Now, with the Moderna and the Pfizer BioNTech vaccines, there were no human cells that were used that were derived from fetal cells in the development or in the production of the vaccines. There was some human cells that were used to study or to confirm that the vaccine would work. And those human cells were derived from fetal tissue. Now, when it comes to the Astrazeneca, and I think Janssen also has a vaccine, as well as the Russian version of a vaccine, there you actually needed those human cells, again, that were derived from fetal cells to not only develop the vaccine and to confirm it works, but also you need these cells for the production of those vaccines. So that is, in a sense, a true statement that there are cells derived from fetal cells that are needed to produce these vaccines. This is where things get complicated, is that the cells that everybody's talking about are of a particular cell line, and it's called, I think it's HEK 293 is the cell line. And what happened is in 1973 in the Netherlands, there was a woman who had an elective abortion, and the biomedical researchers took, I believe, from the fetal liver, some cells that they then cultivated in the lab to form the cell line. And over the years, they've modified the cell line in a number of different ways so that it grows in suspension and that it produces a lot of proteins. And they understand how these cells work inside and out. So these become cells that are used quite often, actually, in biomedical research. So probably almost every drug that we take, is tested at one point in time on these particular cells. And so so it's not like you have to go out and do active abortions and then actively isolate fetal cells, either for the confirmatory studies for the Pfizer, BioNTech, or the Moderna vaccines, or for to produce the Astrazeneca vaccine. These are cells that had been around, a cell line that's been around for about 50 years. These are immortal cells that you grow in a culture. You take some, you freeze them, you take some of those that are frozen, you thaw them out, you grow cultures, and you keep propagating it. So there's probably been thousands and thousands and thousands of propagations over the years. So you're very, very far removed from the actual single event that took place that was clearly an immoral act. So I've actually, as a biochemist, I'm a biochemist, not a bioethicist, I've read extensively some writings from the Vatican, the Pontific, what does it call it? They have a Vatican Academy on Life. Yeah. And then also I've read some pro-life bioethicists who all argue that there's a principle here at play that we need to pay attention to, and that is many times we enjoy the fruits of immoral actions. So the examples that I've seen cited was, for example, the railroads in the United States were built with slave labor and the exploitation of Chinese immigrants. But yet does that mean that if you got on board a train and ride the train, that you somehow are condoning or morally culpable for slavery, right? Or for the exploitation of the Chinese immigrants? Or, for example, Nazi scientists did research on prisoners in concentration camps, and out of that comes chloroquinone, which is used to treat malaria around the world. So if you administer this anti-malarial drug or you take it, does that mean that you somehow are condoning the acts of the Nazi scientists in the concentration camp? So the idea here is that we enjoy many times the good fruits of immoral acts. And in one way you could think about it is that these good fruits offer a type of redemptive basis, or a type of redemption for the immoral act. It doesn't justify it, but it offers some redemptive value to that immoral act. And so that would be the same thing here, is that, look, if I'm a researcher developing a vaccine and I'm using this 50-year-old cell line that, yes, indeed, was derived from a fetal tissue from an abortion, does that mean that I'm actually condoning the act of abortion, right? Or if I receive a vaccine, does that mean I'm condoning the act of abortion? So I tend to be sympathetic to that particular argument and say, yes, it's a tragedy, and there should be a very strong call on research companies and government agencies and scientists to not go down those particular paths as they develop new technologies. But if that happens, does it mean that we necessarily are morally culpable or condoning it if we accept the benefits of it? So it's a very complex, ethical issue, I think. But there's also the common good argument, which is that, by receiving these vaccines, we can build up herd immunity, which mitigates the pain and suffering of millions of people around the world, prevents millions of deaths around the world. And so that also is a pro-life action as well. So this is a complex ethical issue. And I think good people can literally disagree, on what should our response be as Christians who hold to pro-life positions.
Mm-hmm. Yeah, I think it is definitely a place we want to exercise caution. I actually don't really enjoy the arguments that good has come from some of these things, and so it carries value. I think if right now I went out and murdered one person and that murder could cure COVID, I think that murder would still be an immoral act, right?
Oh yes, and there's no question in my mind that I'm staunchly pro-life, and so that one act of abortion that happened in 1973 in the Netherlands was an immoral act.
Yeah.
Right. And maybe even isolating the cells from that fetal tissue, you could argue, was something that should not have been done. Mm-hmm. But now that it's been done and these cells are around and have been around for 50 years, I imagine there's probably researchers that are using these cells that don't even have a full appreciation of the history of the cell line. These are cells that everybody is using to study the effects of drugs or vaccines on humans, right? Yeah. This is the laboratory step that you go before you proceed to animal studies or clinical studies. Yeah. So it's a complex issue, and I wouldn't be opposed to somebody that says I'm really uncomfortable for moral reasons to receive the vaccine. But I also would not condemn somebody who says I see good in receiving the vaccine. So this is the moral conundrum, right? Yeah.
So thinking in terms of bioethics, I think there's a couple of things that also can inform us. One of those things is that this was an abortion done, and the cells were harvested in a secondary act. So to me, this is an important distinction, right? The abortion was done regardless of science and what was going to happen with those cells. Someone did this abortion. A secondary act after that was to harvest some of these cells. I think that's an important distinction because someone wasn't purposely killed particularly for this purpose. At the same time, human beings are substances and we have properties. So what that means is, right, I am Jeff. I am a human. I have a property. My substance is Jeff, me, but my property is brown or now gray hair. My property is I have 5 fingers on the same. But if I were to lose 2 of these fingers, my properties have changed, but my substance has not changed. Why I think this is important is because that fetus that was aborted lost its life. We have not continued to sustain some sort of life, a personhood, and continued to harvest cells from that person. This is the big difference. We're simply harvesting cells that were taken out of a person. It is not a person that we're utilizing anymore. Right. So those 2 distinctions for me are a big thing. And then you get into, how long ago was that? We're not talking 2-3 years ago. We're talking 50 years ago.
Right. And I think an important point too is that there are not ongoing abortions that are taking place to provide the tissue or to provide the cells that are needed to make even like the Astrazeneca, vaccine, right? These are cells that again are immortal cells where there's, vats and vats and vats of these cells all over the world that people are working with. Yeah. So but it's a complex issue, right? That requires, I think, sophisticated analysis. And I really appreciated your input there, Jeff.
Thanks. Okay, a couple more questions. What about the variant of the virus? Is the vaccine going to help protect against that or not? Because we've heard about this coming out now.
Yeah, the short answer is I think it's going to protect us against that variant. And what is a little bit alarming about the variant is it appears to be much more transmissible than other variants of the virus. But just as a point of reference, one statistic that I saw was that there's been 90,000 isolates of the SARS-2 coronavirus from people that have had the genome sequenced. And so we have 90,000 genomes that we've sequenced now. Wow. 12,000 variants have been discovered. And so this is just one of 12,000 variants. Wow. And what's a little concerning is that some of the mutations in this variant are in the spike protein, but as long as it doesn't radically change the 3-dimensional structure of the protein or the surface properties, particularly where antibodies would bind, there's no reason to think that this variant is not going to be, or that the vaccines are not going to be effective against this variant. So and even if the vaccines are not quite as effective against this variant, this is why herd immunity becomes so important. Because if we build up herd immunity against, the virus in general, then we're not going to have to worry about these odd variants that arise where the vaccine may not be as effective.
That's true. That's good. One of the things that I talked about with AJ was she talked about people being concerned about the effects of the not only the virus, but they're actually more concerned about the effect of the vaccine on them. And one of the things she had mentioned was, hey, chances are if you had an adverse reaction to a vaccine, you would have had a very bad reaction to the virus. Have you thought in terms of that, or is that not as big of a deal because it's RNA, or what are your thoughts on that?
Yeah, well, the thing is, I'm not sure I would completely agree with that because, again, part of the concern with having a bad reaction to these RNA vaccines is that RNA can trigger a very strong immune response if it's injected naked into your bloodstream as a naked piece of RNA. Mm-hmm. And your body is designed to respond very strongly to RNA because there are RNA viruses out there. So RNA floating around in your bloodstream isn't a good thing. It's an indication of an invasion of your body, right, by a foreign agent. And so you're not as likely to have that severe of an initial reaction to the SARS-2 coronavirus as you would to naked RNA. So the initial immune response may not be as violent to it. But with the virus, there's all kinds of other complications that arise that are part of COVID-19 that you don't really want. So to me, the allergic reaction that you could have to the vaccine, which again is a very small number of people that are going to have this allergic reaction, is a risk worth taking because we can treat that kind of allergic reaction very quickly. You can dampen down the immune response. We have drugs that are available to do that very quickly.
Like
whereas
we were saying,
you don't want COVID-19, in other words. So, to me, the choice is a no-brainer.
Yeah, I mean, it's a medical intervention. Like we said, any medical intervention does things to your body, changes things, and you can have an immune response. But the odds are the vaccine is going to cause way less problems than COVID-19 could cause inside of you.
Yes.
And is it true that even if you don't have a huge problem, if you get COVID-19 and you don't have a big problem, it can stay inside of you and it could potentially cause problems later on for you, or you could continue to transmit it to other people?
Yeah, well, I mean, even if you are, asymptomatic, or pre-symptomatic, where you're not showing symptoms yet, you can be infectious, right? It looks like once you've been exposed and you've developed COVID-19, it's about 10 days before you stop shedding viruses. So that's now about 10 days, 14 days is the time for quarantine, because that's when you stop shedding the viruses. But nobody really knows what the long-term effects are, and this is where I think I'm really very concerned with COVID-19 is there are some people that have what's called long COVID, where it lasts for months and months and months and they just don't clear it. But even people that have had relatively mild or moderate cases of COVID-19 are now reporting months later, poor taste or poor smell, which is an indication that the virus has invaded your nervous system. They suffer from things like memory loss and trouble with cognition. So there's some neurological effects, there's sleeplessness. Plus, on top of that, can be long-term damage to the heart, to the lungs, to kidneys that we're seeing in people, a heightened occurrence of stroke. One statistic that's a little alarming is that the average age now for hospitalizations is actually under 40 years of age. And of those people that get hospitalized that are in that age group, almost 3% will die. 10% will go on ventilators. 20% will require intensive care treatment. So, this is really a very serious thing, and we don't know what the long-term effects are. And that's to me is really what's really, quite frightening is even if you have a mild case, there may be lingering effects that we don't understand yet.
Good. All right. Someone posted this. It's from a website called BitChute, which I've never heard of before. And they said, as part of our legal action, we have been demanding the evidence that this virus actually exists, but no such studies exist. So there are people talking about there's not actually evidence that COVID-19 is real. That this is actually just the flu or pneumonia or whatever going around. How do we know this is actually a real thing?
Well, I mean, we have isolated the actual virus from people that have COVID-19, and the virus is a coronavirus. It's different from the influenza virus. It's different from the virus that causes pneumonia. So you can visually see differences in the morphology of the viruses compared to the influenza virus, compared to the virus that causes pneumonia. We've sequenced the genome, of this virus, so it is real. And, there's very good evidence, that the symptoms that are connected with COVID-19 are indeed caused by the SARS-2 coronavirus. The COVID-19 is not the flu. It's not the same thing.
Yeah. You say we have, seen the genome, we've seen the actual virus. When you say we, like who is it that has seen it? Is it like some super secret scientist in the CDC lab, but no one else? Or like who has seen it?
Well, I mean, this would be the broader scientific community that has, worked on, these viruses directly. But all of the data has been published in peer-reviewed articles, that are open access in many instances where anybody can get a copy of the paper. and the work, the methodology used by these scientists is published as well, so that anybody could, in principle, go into the lab and replicate the work and to confirm, the results. So if there is a conspiracy afoot, it's a conspiracy that involves hundreds of thousands of scientists all over the world, that are somehow agreeing,
Yeah.
The crazy thing is, though, I mean, we're looking at the convergence of a couple of different worlds here, with the whole the conspiracy theorists, and we're sitting here talking to a scientist about conspiracy theories about the biological genome of a virus. And I mean, I love you to death, Buzz, but watching you try and respond to that was almost like it was hard for you because these two worlds are so different. You know what I mean? Well, I don't believe it exists. It's like saying, well, we didn't go to the moon. You know what I mean? And it's just crazy, dude. But I think you handled that really well. I got to give you mad respect for that.
Well, I mean, to your point, Dave, is that, when somebody develops a conspiracy theory mindset, and I think there's a difference between being skeptical and asking the hard questions. How do I really know that what you're claiming is valid, right? Those are fair questions to ask. But when you develop a conspiracy theory mindset, it goes beyond a healthy skepticism to nothing you can say is going to convince me, because you are obviously part of the conspiracy, right? Mm-hmm. By trying to convince me, right? So there's really nothing that you can ever truly say, but
yeah. There was another viral image going around showing a Pfizer document saying not to have sex for 28 days after you get the vaccine due to reproduction safety. And some people saying, see, it's population control. That's what this really is. What's your response?
I saw that as well. And I really don't know how to respond to that, because I just have no idea mechanistically how the Pfizer or the Moderna vaccines would somehow cause sterility. I just don't know how mechanistically that would work.
Yeah.
So, I don't know how to respond to that other than to say there's absolutely no evidence, for that we've observed. So.
Yeah. Okay. And actually, when I see this, what comes to my mind is if they're actually using this for population control, they wouldn't tell you to just not have sex for 28 days. It'd take a lot longer than that. And if it was actually something in the vaccine that caused you to go sterile, why would they tell you? And so anyway, it's just one of those things. There's lots and lots of warnings everywhere, right? Basically, they're just saying, hey, we don't know what this does to unborn children. So, just be careful, is what it comes down to. One of the things that came to my mind while you were talking about this was what great design our bodies have. We talk about this as being like the teleological argument, the argument from design. All these medical interventions, these scientists who've done amazing discoveries, almost every medical intervention still requires our body to respond properly to the intervention we've made. And you just want to talk about a little bit on how our bodies really show the Creator's ingenious work.
Well, I mean, that's a really good point, because, I am a biochemist. I'm not an immunologist. And in fact, when I was doing my undergraduate and graduate work, I try to avoid immunology like the plague, because it's just this, this nightmare where you've got 10 million different types of cells and all kinds of signaling molecules. And that was just beyond what I wanted to invest effort in, but our immune systems are incredibly complex and incredibly elegant systems that we still are scratching the surface in terms of understanding. But as we continue to penetrate, the insight into our immune systems, they just appear to be even more and more astounding. And so there's an elegance and sophistication that to me suggests design. But these systems are amazing in that they afford us really protection against a wide range of different types of pathogens that we're going to encounter, in the world. And as you're pointing out, Jeff, the vaccines that Pfizer and Moderna have developed that are just in these incredible pieces of science are really just simply taking advantage of our immune systems and just giving our immune systems a little bit of a nudge, right? in the direction that we want it to go in.
Yeah.
And so it's really the response of our immune systems that really is building up the immunity. So, and that's again to your point, or even things like the discovery of antibiotics, which literally revolutionized medicine. These are compounds that are naturally produced, by microorganisms that we just simply discovered and then can tweak a little bit. And now we have, protection against, microorganisms that we can treat infections. But again, it's what's already in nature that we're just simply taking and tweaking just a little bit for our purposes. And I see that as part of God's, not only the design, but part of God's providence.
Yeah.
It's amazing to me to think that soil bacteria would be producing compounds that would be so valuable to medicine. Why would that be, right? Other than that the Creator is built into the creation, all the things that we need. It's really up to us to study the world around us and to take advantage of what God has provided for us.
Awesome. All right. We're coming to the end here. I have 2 questions for you. Second to last question. Are you going to take the vaccine?
Yes. Okay. I would take it tomorrow if it was offered to me. Yeah.
All right. And which one, given your preference, would you go with Moderna, Pfizer, or AstraZeneca?
I would probably prefer to have either the Moderna or the Pfizer BioNTech vaccines. To me, they are in effect the same vaccine. Subtle proprietary differences between the two, but I would take one of those two probably. That would be my preference.
Cool.
But if the only vaccine available is the AstraZeneca, I wouldn't hesitate to go with that either.
Awesome. Thanks a lot, Dr. Rana. And your books are all available at at reasons.org, the Reasons to Believe website. We're going to link to that on our website. What book that you've written gets the closest to a topic like this, do you think?
Probably Humans 2.0, because I do have a section in that book on the CRISPR gene editing and the delivery mechanism for how you would get the CRISPR gene editing package into target cells in our body is the same kind of mechanism that the AstraZeneca vaccine is using,
really?
Which is essentially a viral vector. So there's an interesting overlap between the CRISPR gene editing technology and what AstraZeneca is doing.
See, I was thinking about CRISPR as you were talking about some of this other stuff. But if anyone wants to know about it, we did a show about CRISPR with Dr. Rana. You can just go to truthrevolution.tv and find it. Go ahead and get his book, Humans 2.0. It's a great book. So thanks for joining us today. We really appreciate it.